So in the previous class, we have discussed orthographic projections without sections. So let us recall the conventions of orthographic projections. So here we are using first angle of projection. The conventions of first angle of projection is like this. Front view you will be writing in vertical plane. Top view you will be writing in horizontal plane. And left side view you will be writing on right profile plane, which is located right of the front view, and right side view will be written on left profile plane, which is left side of front view. This is a convention what we are using in orthographic projections. So the output drawing of orthographic projections is 2D. Whenever in the exam they ask orthographic views, means you have to write front view, top view and side view. Side view, if it is not mentioned in the question, you can either write left side view or right side view. If it is mentioned in the question, you have to write that specific view. So this is what we have seen in the previous classes. The limitation of orthographic drawing or projections is whenever the details of drawings are high or whenever the invisible drawing is high. Say for example, if it is having more number of hidden features, the representation of drawing in 2D views will be difficult and time consuming. So in order to simplify the drawing in hidden conventions or different interior details, what we are introducing a plane. That plane will cut the solids into two parts, that is nothing but a section plane or cutting plane, and the view after cutting the solid, that view is called as sectional view. So simply the sectional view is defined as the view obtained after cutting the drawing. So this is nothing but a sectional view. Simply we can say the section is the interior details of the solid. Exterior details already you are representing. In sectional view we are representing the interior view, interior details of the components. So what is the use of representing the interior details? Whenever I represent a drawing in hidden conventions, it will be a dotted line. The dotted line can be anything. It can be a square, it can be a circle. So we need to represent what exactly is that. In some of the views it can be a bolt and nut. In some of the views it can be a stud. In some of the cases it can be a rivet or welding joints. So in order to simplify the drawing and make ease of understanding of hidden features, we were using sectional view. The conventions for sectional view is, we will be representing the sectional view in terms of hatching. So this is a convention what we are using. This hatching indicates the solid is being cut or the solid is sectioned. So this is hatching. The conventions for hatching, usually the angle will be inclined to 45 degree and the spacing, as per the desired convention of drawing ISO standards, the spacing should be 3.5 mm. In order to make the visibility of hatching lines precisely, in software we are using 1.5 mm as a spacing. So this is a convention we will be using in section. Also the representation of cutting plane or the representation of section plane, that is very important. So the section plane is represented like this. So a line with a dash, a line with some dash. If it is having one dash, it is a different thing. If it is having two dash, it is a bisecting line. So the conventions will be different, and this arrow marks is indicated with alphabet S or A. This is the convention we will be representing the cutting plane. And the cutting plane can be anything. you can introduce anywhere in the view. If you are introducing cutting plane in the front view, it is said to be sectional front view. If you are using cutting plane in top view, it is a sectional top view. If you are introducing cutting plane in the side view, it is a sectional side view. The name will be as per the view of section plane. So this is a convention what we are using. So these conventions you have studied in detail in section of solids, which is given by Professor B. Sachin in the previous sessions. So let us see what are the different sectional view in orthographic projections. Number one is full section. Next, half section. Number three, offset section. Aligned section. Next, number five, revolved section. Number six, removed section. Number seven, phantom section. And broken out section. These are the different types of sections we will be using in orthographic projections or in orthographic views. So, full section, the name indicates full section. That means for a solid part, you are introducing a cutting plane parallel to front view or parallel to top view or parallel to side view. That is nothing but it is a full section. In full section, you are introducing a cutting plane in such a way that it will be parallel to the views. Importantly here, in full section, you will be cutting solid initially. That means before that there will be a no section. The first time you are cutting the solid, that is nothing but full section. Most importantly, in full section, there is only one cutting plane. There is only one cutting plane which is parallel to the views. After that, the solid is being cut into two halves. One of the half is retained and that retained portion will be written as sectional view. Second one is half section. The name itself indicates half. That means already there is a cut solid. For that you are introducing a cutting plane. So in case of half section, there are two cutting planes which are orthogonal to each other or perpendicular to each other. In half section, the symmetrical objects will be being cut. Only we cannot use other unsymmetrical component for half section. We have to use only symmetrical section. Whenever you cut a screw jack assembly, that is a half section because it is asymmetrical in nature, and this gives more interior details of the component rather than a full section. Very importantly, almost all the CT scans are all half sections in natures. Next is offset section. So it is a view you obtained after cutting a solid which is set at a distance from the origin, or if the axis is not shown in the solid, then we are using offset section. In offset section, we cannot easily represent that through an axis. It is somewhat located at some distance. And most importantly, offset sections are mainly used for bolt and nuts, which is located at some distance from the axis. And the name itself indicates offset. And in some of the cases, we cannot show the solid in a sheet. In case we will be using offset, because when we represent the offset section, that will be going out from the page. So hexagon, that is one of the example for offset section. Aligned section. In offset section, another important thing is the line, the section plane is 90-degree exact, which is offset parallel to axis. But in case of aligned section, it is inclined to axis. It is inclined to axis. So if you represent aligned section for a ram's bottom safety valve, that is one of the example for this aligned section. Representation of the drum. So the drum is represented from the axis which is inclined. And moreover, the cup and cone arrangement fractures, that is also an example for aligned section. Revolve section. Revolve section is the section after being revolved the part, you will get the solid component. The example for that is the body in the screw jack. The body in the screw jack is a revolve section. The sectional view, if you rotate at an axis, you will get a solid particles. The example for this is revolve section is you taken prisms of revolution. Those are all examples for revolve section. After the revolution of the sectional view, you will get a solid 3D component. And the representation of revolve section is important if the area of cross section is circular. If it is having other cross section, we can easily note down what is the type of cross section using using revolved section. Then removed section. The name itself indicates removed section. The interior details of the drawing cannot be given in a sheet of paper sometimes. So what we will do is we will be reducing the scale. Because of reducing the scale, we cannot notice all the individual dimensions thoroughly. We can't get the dimensions easily. So what we will do is we will be writing separately by having some section. So some of the cases holes at the bottom we cannot show easily. In such cases, we will be using removed section. Removed means the name itself indicates it is removed from the solid. Then phantom section. Very important, there are lots of gears arrangement in a drawing. We need to represent addendum, dedendum, those dimensions. Those dimensions will be used as a phantom section, the sectional plane for gears. Specially designed, hence it is called as phantom section. Broken out section or partial section. The name itself indicates broken out. So what happens for the section, for the sectional view, for the sectioned solid, again we are showing some of the section separately in order to make the visibility of the drawing in detail. So that is nothing but broken out section. So almost all the figures will be indicating the different views of section. In the machine drawing, while reading assembly, all the sections are very important, but most precisely we will be using full section and half section. Again recalling the full section has only one cutting plane, but the half section has two cutting plane which is cut orthogonal to each other. So while representing the drawing also, you need to represent two section plane for half section and one section plane for full section. And again, we will be introducing section only parallel to the views in machine drawing. Let us take up the first problem. Let us see what are the sectional views we have to write. So this part will be 3D. This is showing the three different views: front view, top view and side view. If I write the front view, top view and side view for that, it will remain constant. It is same as the previous case. Orthogonal projection, the first thing, we need to identify the maximum portion of the drawing. So that maximum portion of the drawing will be written on the front view and then other two views will be written based on that. So here in this figure, already they have mentioned the front view. And look at the figure again. The front view, side view and top view you have to write. You have to write orthographic views of the component. And how to identify it is having section or not. In the previous cases, directly they are giving draw the orthographic views of the components. But here they have not mentioned which is to be sectioned or not. In such cases, identify the easier one and take the section of that. So here what I will do is, I will take front view in section. That is easy for me to write. The retained portions of the solids will be written easily. That is very easy to write, front view in section. If it is mentioned, you have to write. And moreover, in most of the problems, they will be asking only sectional front view or sectional side view. There is no problem having sectional top view. That is very important. In the problems, you have only two cases. One is sectional front view and another one is sectional side view. In some cases, what they will ask is, instead of sectional view, they will ask sectional front view, top view and side view. In such cases, you have to write only sectional view for front view. Don't write section view for left side view or top view. Otherwise, they will ask draw the orthographic views for the component shown. A, front view in section. B, top view. C, left side view. In such cases, again you have to write front view in section. So please understand the question correctly and then you start writing the answers. Again, since we are following the first angle of projection, first we have to write front view. Before that, we need to see where to start in the sketchbook. That is very important. Whether I have to start left side or whether I have to start right side. That depends upon side view. Here in the problem, they have asked left side view. Since left side view is located in right profile plane, first you can start front view exactly left of your sketchbook. Because left of your sketchbook you can draw front view, right of your sketchbook it is left side view written on right profile plane. So that convention is, that planning is important. Otherwise what happens? You have to erase and you have to redraw it again. That adds half an hour extra. So in machine drawing, the time management is very important. That decision you have to take within 2 to 3 seconds. So here, the front view is written, top view is written, and side view is written. It is as per the previous conventions what Professor Panduranga has taught. What is an extra thing is you have to draw sectional front view. Sir, can I write ordinary view first and then section? Yes, that is also possible. Sir, can I write directly sectional view? Yes, that is also possible. Whenever they ask a sectional view problem, in the sketchbook left hand side there is an unruled portion. In the unruled portion, first you write the rough sketch. That rough sketch you have to write within 1 minute. After that, you transform that sketch with dimension in the grid sheet. Then it will be easy for you to write the sketch. So 1 minute, please analyze the drawing, because sometimes what happens, wherever you have to draw sections, that is a typical decision will be taking place. So the same thing here, front view already is written, side view and top view already written. And I have to write a sectional front view. Sectional front view is nothing but you are introducing a cutting plane parallel to the front view. That is nothing but sectional front view. See here, cutting plane is parallel to front view. That is a cutting plane they have indicated. So that is being cut. You cut that. The solid will be divided into two parts. You remove first half, you retain second half, which is projected to the board. And you have to write that retained portion. In that retained portion, very importantly, you have to observe the hidden lines of the circle is converted into dark lines or visible edges. Why visible edges? Because of introduce of cutting plane. That cutting plane is converted hidden edges as a visible edges, and you have to show that by hatching. So the sectional front view is as shown in figure. That hatching, that is a retained portion of the machine component, and that hatching convention, again I told, it is 45 degree. Hatching indicates the material inside the solid. So here there is no hatching for this circle because there is no material. Wherever there is a material, there is a hatching. Very importantly, you have to know this is a sectioned plane. In some of the cases, ribs you can section or you cannot section. If the rib is having large, you need not be sectioned, just you show a rib, that's all. And also one of the important thing is here the object is cut through the axis. Through the axis. If it is cut on the back side or from distance from the axis, everything is hatched. Everything is to be hatched because at the center there is no material for the solid component. That's why it is empty. It is not hatched. Only side portions are hatched in this diagram. And there is a rib at the center that is hatched. In some cases, you have to identify the components in such a way that first, what are the features are being cut? Very important. If you miss circle, and if the circle has no material, you have not shown hatching, no problem. But the section plane is passing on the circle. If you not show the section plane through hatching, then the marks will be reduced. So be careful, identify the features which is being cut. Here rib is being cut, circle is being cut, and two big circles is also being cut, and those things are hatched. And after that, please write the name sectional front view. Earlier you are writing front view, top view and side view. Now you have to write sectional front view. So this is the first problem in orthographic views in sections. Again, recalling the convention, hatching is very important. First you have to identify which view to be sectioned. Second thing is, what are the features are there in cutting plane? You have to identify that, and those features you have to show. So maximum cases, either front view is being sectioned or side view is being sectioned. So there are several other problems. You just go through it. Only the change is sectioned, and this convention you have to follow. While drawing this hatching line in the sketchbook, please use two protractors and make it a 45-degree line. So just you place one protractor at 45-degree line, then other protractor you lock it and then write. Then the time will be easy for you. And this should be darkened. Closer the lines, the view looks better. If you just use a rough line, we will give a rough marks. So be careful while representing this. And in some cases you say, for example, assembly drawings like screw jack, plumber block, machine vise. In that, we have to represent this cutting plane in the top view. In the machine drawing, orthographic views, we are not representing any cutting planes. So directly it will be given in the 3D figure or isometric view. That will be just we are writing that figure. That we are converting that 3D to a 2D very easily, and we are not writing any cutting plane in any of the views. So in assembly drawings, compulsorily you have to write the sectional views. Sectional cutting plane as well as sectional views. Screw jack, if you take, it is a half section. Plumber block, if you take, it is a half section. Or half section in front view. You will be written the sectional view in the front view, but in the top view, you will be failing to represent the sectional plane. Very important. So again, I will repeat this. In assembly, you have to represent the cutting plane in the top view in assembly drawings, as well as you have to write the front view in section. Machine wise, it is a full section. So like this, we are using different types of sections in orthographic projections. So 5 problems are there. Just go through it and just analyze the views of section. And while drawing a cutting plane itself, while seeing the cutting plane itself, you have to identify how many features are being cut. In some of the cases, the cutting plane will be offset to some axis in order to show other detailing. If it is parallel, then no problem. If it is straight, then there is no problem. It is at axis. If it is inclined, if it is offset section, then you have to identify the different views of the component. Thank you.